Richard. Hi everyone, thank you for joining. I'm Sonika. I work at Google and I'm joined by Marcus. So we'll be talking about how we can use multi-node deployments for virtual test beds using Active. So to give a bit of a background, Active is part of Alpine framework. Alpine framework is a framework we defined about 1.5 to 2 years ago to assist in SONiC development as well as testing. And it consists of three parts. The first is the Alpine virtual switch. We have talked about Alpine virtual switch in various other places as well. So it is a SONiC virtual switch with a data plane. And the second part of it is to how to deploy these virtual switches in virtual test beds. And we use KNE for that. It is referred to as KNE Active, which is Alpine KNE test beds. The focus of this talk will be Active. The third part of Alpine framework is really how all the infra around enabling the test to run against these virtual test beds, and we refer to it as Apex, which is Alpine pre and post executions, to really call out that for pre-submit validations as well as post-submit validations, we can use Alpine virtual switch and Active environments. So as I mentioned, we use KNE for deployment of these virtual test beds. And KNE stands for Kubernetes Network Emulation. Marcus will talk more about it. And so it is an open source tool developed by Google. And it provides simple way of defining the topologies in protobuf format in the form of nodes and links. It is built upon some of these builder technologies like Kubernetes Topo as well as Meshnet CNI. What Active provides is the way to deploy these SONiC virtual switches. Particularly, we have started with AVS to deploy it in KNE, and which enables us to test the interoperability with different kind of virtual switches, and we could also add in different kind of emulations also into the same test bed. So this is a very simple example of a test bed we deploy using Active, where we have two DUTs. One is the Alpine control switch and other is a DUT. Both of them are defined in a protobuf format as simple as like this, where each node is defined like this, where the images of these nodes are pulled in at the time of deployment. You can see the image names here. They are pulled in from the Docker registry during at the time of deployment. The links between these are the data links, which creates the data ports for the virtual switches. They are defined as links like this, and any services which we enable on the virtual switch are enabled on the port. So really, it is a very readable format for a test bed. So to see the real use of KNE and underlying Kubernetes, we performed a kind of a POC for deploying a virtual testbed across multiple cloud VMs. And this is one of the topology we created, where we created a ring topology of 10 virtual switches deployed across 4 nodes. And each of these virtual switches started with 2 data ports, 2 links, one connected to each peer. And once we had all of this set up, so you can see there are 4 nodes. This is a representation. In reality, Kubernetes can deploy or load balance these virtual switches across any of these nodes. So when I say Kubernetes node, I'm talking about a GCE instance, a GCE VM. A Google Cloud VM. So these are really 4 different Google Cloud VMs, the emulation created, and deployed load balance the 10 virtual switches across these 4 different GCP VMs. So once we deployed this, we configured manually all the 10 switches with simple forwarding rules, like just to forward to the next port, and then injected a traffic. Injected one packet from one AVS, and then checked all the counters on the different switches. So this was a POC we did to showcase that the KNE can be used to create larger topologies across different GCP VMs. So since there is no real limit on the number of virtual switches we can create by using KNE at the lower layer. So as the next step, we also tried a POC with active deployment of 100 virtual switches, 100 AVS virtual switches across 40 nodes. So this, just to give a rough idea, the topology creation, the emulation took about 10 minutes to create a 10 AVS switches across 40 nodes. So this is just an example use case which we can think of. This is like a food for thought. So currently SONiC topologies are deployed in a different way using SONiC management. So it has SONiC topologies have multiple logical topologies. So we can bring up entirely the complete SONiC topology entirely within Active. So this is an example T1 topology I've tried to bring up, show here. So there is a SONiC DUT. Each of them will be defined in the topology file like this. The DUT with, I'm taking an example of an Alpine AVS switch here, and all the other nodes, all the other switches could be either some fake switches or real virtual switch devices or any kind of emulated devices. And this is how the topology file would look like. It will have a bunch of nodes in it and all the links connecting to connecting all the different devices. And this entire topology can be brought up in cloud with using KNE. So this is just an example, and I will hand over to Marcus for KNE details.
Howdy, everybody. Marcus Hines. I'm a software engineer at Google, and my focus is actually on KNE. I'm the creator of it. We actually created this as part of the Open Config Forum. I'm also a member of that. And the goal, the previous talk actually is really interesting because kind of different goals, outcomes that we're looking for out of why we did KNE. KNE, we actually use specifically an Open Config for all of our functional testing of all the various vendor implementations of all of the Open Config protocols. So those are GNMI, GNOI, GNSI, all them things that start with G. And so what we needed to be able to do is actually not own everything about emulation. So one of the nice things about using Kubernetes for this is we can use operators and hand those to vendors and say, hey, vendors, y'all need to be responsible for your life cycles of your containers so that when they come up in our emulations, they come up consistently. So that is one of our biggest goals there is all of our vendors own their own implementations of operators. We own the bring up lifecycle manager within the KNE ecosystem, and we own all of the gRPC wires. The way KNE works is, we have a simple CLI tool, and basically you define a proto like Sonika showed, and you can say what nodes you want, what topology you want, and then basically depending on where you want to run, because you can run this on your laptop, you can run it in a VM, or you can run it in a cloud, and so that lets you just get different sizings. And so as Sonika mentioned, we do support in general, you can support between 10 to 100 nodes per worker instance. Obviously, there's a lot of CPU, memory, what kind of device you're looking for. And we actually do scale up to about 10,000 virtual nodes inside of a KNE, and that's with 100 worker instances. And that does work. Now, our data plane is all over gRPC. So it's over user space. So you get very good fidelity of operation, meaning MTU isn't a problem because you're not going through VXLANs and things like that. But performance is not a goal here. We're not trying to for millions of packets per second. We're really looking for correctness and then validation of routing behavior across an entire emulated fabric. We also really focus on the external service dependencies, because a lot of times in OC we're testing the service interactions of services outside talking on through the G star APIs onto these emulations. So as we talked about gRPC wire, we also, it's called MeshNet. It's actually a CNI plugin into the Kubernetes. It's not very complicated. It really just says, hey, based on that topology, let's go build some gRPC connections between all of these wherever KNE laid out these worker nodes, and then the pods within those worker nodes. and gives us a layer 2 connection between everything. So this is actually just a really simple KNE topology. Basically, you can take that proto, render it into a little SVG, but that's basically what's going to get created and laid out automatically based on the KNE create. As far as within the KNE ecosystem, pretty much download KNE off it's open source under open config, and you get a CLI. First thing you need to do is deploy your cluster, which is going to basically set up a KNE instance, whether you can run it in kind on a laptop. So that's the smallest version of things, or you can have your cloud wired to it, and you can deploy this onto GCE, Amazon, whatever you want. And that deployment will specify all the base level wiring and containers and sizing that you're going to want to be able to use. And then topology management, that's this piece Sonika showed, was really all you do is a topology create based on whatever topology you defined. And in theory, in PowerPoint, everything's going to come up and you'll be ready to actually interact with all of those pods. And so the way we expose that is all through just standard Kubernetes services. So you basically have SSH access into all of your devices, and you can add more connectivity if you want through defining more services. So if you want to be able to access GNMI from outside the cluster from all of your devices, which for us, we do a lot. So all of those services are exported that way in a standard format.
All right, thank you, Marcus. So these are some of the call to action. So we do run a SONiC virtual data plane group. That is where the charter of the group is, working group is SONiC, VPP, Alpine, and more. So you're welcome to join it. The meetings are Tuesdays at 9 a.m. and we do have a breakout session as well. And of course, contributions are welcome in all the 3 repositories. So KNE repository and Lucius is the data plane, which we use in Alpine Virtual Switch. And of course, the Alpine repository itself.
Two quick questions. The schema looks a little maltish. Is there any relationship between malt and none? Okay. The second question is, do you have tools to package VMs to work with KNE, or does VMs just work naturally with it?
So VMs can work with it. We do try to only use containers just because it's a little lighter, but you can absolutely wrap a VM in a container. So we have some vendors who actually offer, because whenever we want to do ASIC simulation, vendors like specifically Cisco and Juniper both make a simulation specific VM that they just simply wrap in a container, and then you can start that container and it has all the normal wirings.
Yeah,
Alpine
with Container
Virtual
Lab,
Switch is
they
also-
have.
Alpine Virtual Switch is also the same thing. It is a VM wrapped in a container.
Okay, yeah. Container Lab has a tool called VRNet Lab where you can wrap. You have anything similar to that, or just
Actually, we probably just use that. So we
you
actually
just
work,
use it? Okay.
we actually work with Container Lab a lot. Like
Yeah.
Roman Dodden, he actually has contributed into KNE as well.
Okay, cool.
Yeah.
Hi, one interesting point that I saw in your presentation is that you mentioned you also emulate T2 topology. So I wonder, when you emulate the T2 topology, how did you emulate the backplane links?
No, we did
VOQ?
not. This was an example that we could do that, but entirely within KNE. We have not POC'd this one.
Oh, you mean you never tried it?
No, we have not tried it. We have tried
Okay.
these 100 virtual switch topologies in KNE, but not the SONiC topologies as such.
Okay, thanks.